Welcome to the series of introductory lessons related to the time value of money. My name is Brent Pritchard. I teach college finance courses, and I'm here to help you grasp this all-important concept. This introductory series is designed to help you learn how to apply the mathematics of finance in less than a month, provided you commit to one or more lessons a day. It's that easy. Acquiring the hard skill that is the mathematics of finance does not need to be hard. I hope you enjoy this fun new take on this age-old concept. And after you've done that, please consider telling your friends about this channel, TVM Rules, and the book, Would Your Boomerang Return, also known as the Boomerang Book, that made it possible. I like to start every class with a quote, so here we go with the quote of the lesson. From Abraham Lincoln, "The best way to predict the future is to create it." The focus of this lesson is PV and FV. In particular, how the present value isn't always as of today or period marker 0 on the timeline, and similarly, how the future value isn't always a certain number of periods from now. Don't let the word present of present value and future of future value throw you off. A better way to think about present value and future value is that both are as of certain points in time. To illustrate this point, we're going to use a string. And for this string, let's let the leftmost side represent present value and the rightmost side represent future value. And we're going to change things up for this illustration, and we're going to assume that period marker 0 is in fact today. So let me draw a timeline. I'm actually going to draw two to illustrate this point. This is period marker 0, period marker 5, period marker 10, and I'm going to fill in the blanks because I have time. Thank you for giving me your time, your most precious resource. 1, 2, 3, 4. Here's the 6th period marker, all the way up to the 10th period marker. Now remember our string. The rightmost side represents future value, and the leftmost side represents present value. So if we were to look at the string, here we have present value, and I know that's a little hard to see, and here we have future value, but I've shown it below the timeline. Remember, we said that for this example that has more words than numbers, there's not one number associated with this example. We did assume that time period 0 is now. So let's think about this a little bit. The present value, it's as of the end of the 5th period. That's 5 years from now. So there's nothing that says, there's nothing today about the present value in this first timeline. The present value is as of 5 periods from now or today. Now let's draw another timeline. It's a shorter timeline. This timeline has 5 periods. And we're also going to fill in the blanks. And what we're ultimately solving for in this example that includes all words and no numbers is the present value as of today. So to use a convention that I've used before with the TVM wallets, I'm going to put a rectangle around this PV because that's the intermediate step. We first want to find the present value as of the end of the 5th period so that we can ultimately find the present value as of period marker 0. And I'm careful to say period marker 0 because that might be today, it might not be today or now. So in this kind of situation, there's this intermediate step where we've got to perform what I call the switcheroo. And the switcheroo involves switching the sign of the present value and turning it into a future value so that we can ultimately solve for the present value as of period marker 0. Again, let's look at the string. This is the rightmost side of the string. That represents a future value. The leftmost side of the string, this represents present value. So I hope that helps. Now let's move on to a real world situation. But before we analyze this real world situation, I've got a couple things I'd like to point out. Remember, the present isn't always as of today or period marker 0, and the future is not always a certain number of periods from now. But there's another thing that I want to point out. In this situation, lowercase I, or the true investment yield, takes the form of the compound annual inflation rate. Call it investment appreciation. Now, some people might call that the compound annual growth rate, but I wanted to present it the way that I did because I think the order of the words matter. We like to think in terms of the true, fill in the blank for the term, investment yield. What does the word true mean in the context of the time value of money? Well, it means that the effects of compounding have been considered. Here, inflation is another word for investment appreciation or growth. And we know that rate and yield are words that are used interchangeably. So the compound annual inflation rate can be thought of as a kind of true annual investment yield. So let's draw a TVM wallet and answer this question. Let's analyze and evaluate this real world time value of money situation. Here's our TVM wallet with its 3 windows. I'm going to write in the 5 primary time value of money inputs or variables. And here we have our timeline in the first window of the TVM wallet. This house was purchased for $375,000. And we're trying to figure out what's the future value. How are we telling time in between period markers? This is always one of the first steps. It's technically the second step because first we want to count money. And what that means is, do we have a single payment or an annuity? Now we're telling time, so we're filling in the blanks. And then we move on to reading and writing I, which is the true investment yield, which in this case is a true annual investment yield, or more specifically, a compound annual inflation rate. So we're telling time with an annual time span in between period markers. So we're going to fill in the blank down here in the subscript for uppercase N so that we remember how we're telling time if we forget. Now we know that only a true annual investment yield is going to work. There are 10 periods on this timeline. We're solving for future value. We have a value of negative $375,000 for PV, a 0 value for PMT payment because there's no annuity here. And we were given the compound annual inflation rate, which, I mean, if it quacks like a duck, it's a duck. That acts a lot like a true annual investment yield here, which is why it's going to work. And when we solve for the future value, we get $610,835.49. So that's our answer. I'm going to clean up the 9 there. Clean up the 6 too while I'm at it. I'll just clean up a lot of these numbers. 610, 835, 49. So there we go. That is the future value. But I want to point something else out. This right here is technically today. Well, isn't that kind of interesting? So you're telling me that the present is the end of the 10th period. And for this situation, that's true because this house was purchased 10 years ago. It was purchased. Money's left your parents' hands. They bought the house. That's where the negative sign comes in, the negative sign that's associated with $375,000. The future value has a positive no sign value for the $610,835.49. Let's not forget the cents. I'm sure they're not going to include the cents in the listing price, but that is the number. And so there we go. That's how we solve for future value. Now let's double check our work like we like to do. And here we use the building block future value equation. And here is the building block future value equation. Present value times 1 plus I. Again, that's the true investment yield. Here it takes the form of the true annual investment yield, but it's actually the compound annual inflation rate. So it's pretty cool how the TVM formula has an undercurrent of consistency so that we can do this. So FV equals present value, $375,000 times 1 plus the decimal form of the compound annual inflation rate. And we raise this to the power of 10. We solve for future value and we get that number, $610,835.49. So we're going to circle it. There's our answer. So that's a wrap. If you like what you learned in this lesson, please consider telling your friends about this channel, TVM Rules, and the book that made it possible. It's important that we think through the situation at hand. We saw this in the real-world example that included a future value that was as of today and a compound annual inflation rate that worked as the input for lowercase I, the true investment yield. In the book, Would Your Boomerang Return?, you'll find 23 real-world time value of money questions, space to work out answers, and a baseball count system to evaluate understanding of the different types of questions. If you haven't purchased your copy yet, all the important information on this all-important topic is gift-wrapped within the cover of Would Your Boomerang Return? Until next time, enjoy the gift that is the present.